This is problem 2 on practice exam 8 of chapter 2 in the book Problem Solving with Differential and Integral Calculus. We have the square root of x versus x, and conventionally we say y, the vertical axis, is the square root of x. If we change x by delta x, y changes by delta y. So part A is solve the equation for delta y assuming that it's infinitesimal. So we're going to use dy. And we're going to square both sides before we do it to make it easier. So let's focus on part A. There's the difference equation. We're going to assume the changes are infinitesimal. So now we have that, and we're going to square both sides to get rid of the square root. And we're going to square that out. We get y squared plus 2y dy plus dy squared. We can throw out the dy squared. It's infinitely smaller than dy. So now we have this. And we know that y squared is x because y is the square root of x. We can get rid of those, and we get 2y dy is dx. We want to solve this for dy only in terms of x and dx. So first we divide both sides by dy, and then for y, we substitute in the square root of x because that's the normal equation. So now this is the derivative of y dx over 2 times the square root of x. Now we have to check that answer by getting the square root of 25.008 with the derivative. The derivative is that. So we know the square root of 25 is 5, and we know that the square root of 25.008 is slightly bigger than 5. So it's dy bigger than 5, just about. Not exact. So 0.005 and then 2 times the square root of x. Square root of 25 is 5, so that's just 10 in the bottom, so that makes it 10 times smaller. We're dividing by 10. So that is the difference in y. So the square root of 25.008 is about 5.0008. We can use a calculator, plug in the square root of 25.008, and we get 5.000799, which is very close to 5.008. It's actually 5.008000. And we're happy with that.